Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we will be talking about the use of the surveyor aiding the design of a chrome cobalt removable partial denture. Let's say that some of our patients come to our dental clinic with missing teeth. They have extracted these teeth for multiple reasons. And we know by now that there will be changes in the tissue after extraction. To allow the patient to go back into function, we need to replace these missing areas using partial dentures. Partial dentures come in multiple forms. Today we will be talking about a specific type that uses metal in it. This is different from the one you began your labs with, where you have done the partial denture totally out of acrylic. We are now using chrome cobalt as a material for the removable partial denture. So we need to construct a framework. On the framework, we need to add teeth, and then we're going to change wax into actual acrylic, and we will have different designs of removable partial dentures depending on the patient's situation. If I take one of these cases, let me take this because with the cast on, you would find that I need to add multiple components around the teeth to utilize features already present in the oral structure. For any denture to function, it should have three principles. These are support, it must be well supported, it must be retentive, resisting removal during function, and it also should be stable. So to satisfy all of these requirements, having good support, having good retention, and having good stability while doing the function, the RPD should be designed taking account and utilizing features already present in the remaining dental structures and the soft tissue and bone. To utilize these features correctly, I need, for example, to add a clasp for retention. Where do I place the end of this clasp? I need to decide where to end this clasp. Is this a correct place to put this clasp? Is this a correct place to put a clasp? Is this undercut sufficient for this clasp to be in function? Might I need to change the position of this clasp or leave it as it is? These decisions cannot be taken using your vision. So if I go to an enlarged tooth, this is what we call an abutment. This is the tooth I'm going to talk about, which is adjacent to the edentulous area. Suppose that we have the edentulous area on this side, and this will be our abutment, and we need to add a clasp here. So go back to the question, do I end my clasp here, here, here? Do I need to put it more inside? Could I end a clasp here? The decision where to end a clasp has many factors determining it, including aesthetics, including the health of the tissue, and including utilizing features of the tooth. One of these features is the presence of an undercut. This undercut is the area away or inside beneath the maximum bulge of the tooth. How can I measure this undercut? Using my vision, I could not. I need a tool to actually tell me where is the undercut located first, and do I utilize this shallow undercut or do I need to go deeper or deeper? And how do I differentiate between different undercuts' depth? I need a tool. Our tool for today to decide and look at the cast in a systematic way is called dental surveyor. The dental surveyor is a paralleling instrument used in the fabrication of removable partial denture. What do I mean by paralleling? I mean that any position I place this instrument coming down from the tool, the surveyor, at any position, these positions are all parallel with each other at all these locations. So I need to make sure that the tool is coming down in a way that is controlled and fixed at all times. The only thing changing in this location is the location of the last instrument in this tool. And this last instrument at the moment is the analyzing rod. We will be talking about that in a moment. Now let's take a closer look at this tool, which is called the surveyor, and its components. We would find this tool composing of the following parts. The first part is the base. This stabilizes the whole tool on a table, and it is horizontal to the floor. Then we have a vertical arm holding the instruments that we will be using. Then we have a horizontal arm that can be moved in multiple planes, in a single horizontal plane, but still we can move it. And then we have the spindle, which is another vertical arm, but it has the ability to move. Its movement is also facilitated by the spring, where it puts it back into location, and it goes down into this part. This is the tool holder, and we use it to attach our instruments that we will be utilizing during the surveying. But let's go back to the base, and on the other side it holds another structure called the table. You can see the surveyor table. On the surveyor table, we usually place our casts. So suppose this is a cast I'll be surveying. I'll be putting it on this table and then fixing it with the screw until these clamps hold it into location. Here it's fixed by screw, but in other surveyors you might have it as a spring that clutches on the cast. This table is attached to a ball and socket. This ball and socket allows this table to move in multiple directions, but for the purpose of demonstration for today, we will use what we call zero tilt. A zero tilt means that the table is parallel to the base of the surveyor, and all together they are parallel to the floor. So we are talking about a totally horizontal plane. Once we place the cast over the table, we also should make sure that the cast is trimmed by a way that the occlusal table is also parallel with the floor. Okay, so now let us take a closer look at the instruments we attach. And now we will take a closer look at the instruments we use with the surveyor. First, we will begin with the analyzing rod. It is a metal shaft that has two parallel sides, and it's utilized to locate undercuts during cast analysis. The second instrument is the carbon marker. This carbon marker is used to draw on the cast, draw example survey lines. This is the sheath. It's a metal sheath. It is used to reinforce the carbon marker during the process of surveying and to support it and preventing it from fracture. The third instrument is the wax trimmers. Usually one wax trimmer comes with each surveyor. There are some wax trimmers where the knife or the sharp edge is on the side. There are other wax trimmers where the sharp edge is on the end. So this works in a vertical motion, while this goes around the cast in a horizontal motion to remove wax. These are undercut gauges. They measure the amount of undercut. You can find, if you look closely at these undercut gauges, that they have different sizes. They have the same vertical component as the analyzing rod, but on the end of them, they have another component with different measurements. This part, horizontal part, is the undercut gauge itself, where it measures the undercut in relation perpendicular to the vertical part. As you see, we have a small, a bit larger, and larger. These have specific measurements. This is 0.01 inch. This goes vertically inside 0.02 inch, and this goes vertically to the inside by 0.03 inch. To visually aid their identification, there are slots placed on the instrument. You can find 1 slot, 2 slots, 3 slots as a groove carved in the instrument, just to aid in quick identification of their measurements. And one of the most...
Again, please. Yeah.
To understand the most basic process of surveying, looking for undercuts, we will use this part of the demo to show you the importance of presence of an undercut for retention. This partial denture needs to be retentive, so it needs to extend some of its metal components into areas called undercuts. To make this denture retentive, meaning resisting its vertical dislodgement during function. For example, sticky food will be working on the closer surface so that it will stick and grab the RPD and try to take it outside. We need to prevent this action. So for this rigid metal component to resist this dislodging force, it needs to go into an undercut. So let's take a closer look on this tooth. I want to end my clasp in a way where I could hold this RPD holds in place. I will take this instrument, the instrument as a clasp. Suppose I want to have the patient is going to bite on sticky food. He loves chewing gum, for example, or a piece of sweet, and he's using this RPD, the removable partial denture. If the clasp is located on this side of the tooth, it slips away during function because the sticky food in this area is taking the denture out of its place. So there's no grip because each time this rigid metal component is moving, it simply goes out of the tooth. But if I place this metal component in an undercut, I will have a grip, a better grip on the tooth. Okay, so any vertical motion is resisted by the tooth being located firmly inside the bone socket. So this is called retention, meaning prevention of dislodging forces. So to locate this metal component, I need to know where is the presence of the undercut. So let's take a bit simpler model showing an object that is oblique and round. In a way, a simpler demonstration of the tooth. I would find that we have what we call the maximum bulge. This is similar to natural tooth morphology, where some of their locations on the tooth, we will have a maximum bulge. If we look at it vertically, we will find that there are areas hidden from this vertical path. This is what we call undercuts, hidden inside. And I need to make sure where is the maximum bulge, because by vision alone, I would not be able to decide where it is. I need an instrument to draw this. And also, once I got the survey line, which is on the maximum bulge of the tooth, I need to know which undercut depth should I use. So the idea is, I would use the analyzing rod first to locate the maximum bulge. Then I would use the carbon marker to draw this line. Just by running across the surface, I would find a line drawn on the cast. So utilizing the carbon marker parallel to the path of insertion that I would like the denture to go in by, if we draw on the bulge, we will find that a line is now present. This is what we call the survey line. It is automatically located on the maximum bulge of the tooth. Now I could specifically and confidently say this is the maximum bulge of the tooth using those instruments. Anything below this is the area of the undercut, hidden from the vertical path of insertion, and we could utilize it. The amount of undercut utilized in a tooth is dependent on the material we're going to use. Suppose this instrument is a stainless steel wire, and suppose this instrument end is a chrome cobalt. This chrome cobalt is more rigid from the stainless steel wire you have used in your RPD when wire bending. That means the amount of undercut I should use for this one is less than the undercut I use for the stainless steel wire. So at what measurement should I use? I need to gauge the undercut. This is the philosophy behind having a vertical component to your... So this is the philosophy behind having a vertical component of the undercut gauge and a horizontal component of the undercut gauge. So to make sure I'm measuring this correctly, I should have 2 points of contact. One here on the vertical and one here on the horizontal. If I'm looking at this undercut, the vertical is not touching, so this is incorrect. If I'm looking down at this undercut, the horizontal component is not touching the tooth, so this is also incorrect. They should have 2 simultaneous contacts on the tooth at the same time to make sure that this undercut is measured correctly. We will now redo it on the tooth on the cast. Thank you. So in the first part, we explained the idea of having clasps engaging inside undercuts. Now we're going to take a closer look at another part of the chrome cobalt denture, which is the area of the rest and the guide plane. If I take it on the cast, we see that the rest and the guide plane inside should touch the tooth from the side. If I take a closer look at it, I would find the clasp going into the tooth, and on the side it's touching the tooth. This is what we call a guide plane. I'll be talking about that in a moment. But let us explain the function of the wax trimmer. For example, if the metal is touching the tooth on the rest side, here, in the rest area, and the metal is touching the tooth on the bulge area proximally, because the free inside or the bridge area where teeth are lost is on this side, there should be an area where the metal components do not touch the tooth, because the gingiva is present here around the tooth, which is the soft tissue color around the tooth. If this soft tissue color is traumatized by the rigid metal components, we will lose the gingival health and we will have problems. Now we'll talk about the path of insertion in and out for the removable partial denture. It's called the removable partial denture because simply the patient has the ability to take it out, clean it, sleep without it, and then put it back once he wants to function using it. This insertion and removal is better to be in a single path, going in one direction. This makes the RPD more biocompatible to the tissue. To guarantee this single path of insertion and removal, we have guide planes, which is a flat area on the side of the tooth. Let us revise first the anatomy of a tooth. Teeth naturally come with smooth contours all around. They are continuous contours. They come in convex shape with areas of their maximum bulge in different locations. For example, this is the proximal side, the location is higher. On the palatal, it's a bit lower. Other proximal side, we go back higher. So we have different locations of the maximum contour for the tooth. These natural surfaces mean that if I'm going to be crossing over this component, this is the proximal side, for example, and a metal component wants to go in and out. In this case, if I look at it from the side, I could come in and out from this side. I could come in and out in this direction. I could come in and out from this direction. I could come in and out from this direction. So multiple directions to go in. This makes it not compatible for the tooth health or the dental health. So I need to use only one path of insertion and removal. So how do I do that? By carving in a flat area on this proximal surface. So using a burr on high speed, I could reduce slightly the enamel on this proximal side, and this makes this enamel area flat. As you can see, this area is now flat, and it allows to have one direction for the insertion and removal. You can see it more clearly if I take this representing the rest, the guide plane, and the rest of the metal components. So we call this the guide plane on the tooth. We call it on the metal framework the proximal plate. So the proximal plate is located on the guide plane. So once this RPD goes in and out, it has only one direction to go in and out this location. So this RPD has one direction to go in and out this tooth into its location. This is more obvious when we have two opposing abutments. In this case, going back to this case, we have two opposing components. We have this guide plane, as you see in green, and we have this guide plane. So going in and out would be in a single direction in bounded areas. So how do I determine where to place my guide planes? This is another function of the surveyor, where I decide what is the best tilt by which guide planes are present on the teeth, and then I trim them in the clinic. Now we're going to talk about the blockout procedure. Remember that we said that metal will be touching the tooth in various areas. It will go in and out. And during function and biting, these metal components will be moving slightly. So we want the metal contacts for stability, to have the stability of the RPD. We have to have it close contact on the occlusal surface, close fit and contact on the proximal surface. But we don't want to touch the gingiva around the tooth in this area. The gingiva is in this area as the form of a papilla. Okay? And if the metal component moves and touches this papilla, it will traumatize it. Traumatization of the gingival collar around the tooth would cause later periodontal problems. So we need to add a blockout. We add a blockout in the form of wax. Wax is added beneath the metal to make sure that this metal part close to the gingiva does not touch the tooth, and it's protecting the gingiva. So it's flowing away from the gingiva. This structure that we added in wax is called the blockout. So a blockout material is placed beneath the guide plane to protect the gingiva. The way we place this wax should be parallel to the path of insertion. If I'm going to add the blockout at the beginning, usually I bring and melt down some wax, but this wax is irregular, bulging, and it's not in the path of insertion. So I need to trim it down using the wax trimmer. So if this is the wax trimmer, suppose this is the wax trimmer, it will be trimming down this wax. After trimming the wax, we would find that the path of insertion now is parallel with the wax blockout. This is produced by using the trimmer, the wax trimmer of the surveyor. So if I'm going to do a blockout on this cast, I want to make sure that my wax is parallel to the path of insertion. The paralleling instrument is the surveyor itself. So in any location, this line is parallel to this line and parallel to this line. If I fix the cast into location. It's now fixed. And I use this instrument. Now I could carve the wax in the blockout area. I expose the guide plane area and I leave the wax in the lower part of the cast. This is the function of the wax trimmer. So now the guide plane, the wax blockout are in parallel. If I take a closer look here, this is the palatal surface. Also, there is a component of the metal on the palatal surface of the tooth. But please notice that in this final RPD, metal RPD, that the gingiva here is protected from the intermittent forces during occlusion and during function by the area that was blocked out and eliminated while the procedure of metal fabrication. So the final metal now is away from the gingival margin, protecting it. Now we'll do a quick overview of the RPD procedure and see where we will use the surveying process. First, we have in lab 1, the patient would have had an impression, and this is the primary cast resulting from the primary impression. It's made out of plaster. Here we do the first surveying stage, where we do an initial survey. In second lab, we should have designed our RPD, and we do what we call tooth preparations. In this case, we can see that there's a rest prepared here, a rest prepared here, a rest prepared on this side, and we have done some adjustments inside the patient's mouth. And we take another impression. We do a second survey, which we call the final survey. And by it, we draw the design for the RPD that we're going to do. Later, this cast itself is going to have multiple areas of blockout. You can see that there are multiple areas where wax is added in a planned way. This is the gauged blockout. This is an arbitrary blockout between the embrasure, here on the embrasure. We will have parallel blockout, and we will have what we call shaped blockout. You will take those in detail in your lecture. Here we also use our instrument, surveying instrument, where we here remove the wax, the excess wax on the proximal surfaces, to make sure that this proximal surface with the blockout are all parallel to the path of insertion. So here we use the wax trimmer step. Later, we will change this cast, secondary cast, to a refractory cast. On this refractory cast, we do the final wax up of the metal framework using the wax patterns. Wax patterns have the same shape and sizes and dimensions of the metal framework that we will use later on. This step does not need any surveying. On this final step, we might just need, where metal is ready, we might need a bit of surveying just to make sure if I'm going to extend the acryl into here, I need to make sure that there are no interferences. So here, we will use the surveying as well to locate areas of interferences that might need to be removed before processing the acryl. So this is optional, but these are the main points where we do the surveying. So once more, an initial survey, final survey for the design, wax trimming for parallel blockout, and maybe for interferences, optional if there are soft tissue interferences that might interfere with the acryl. The refractory cast does not have any surveying step.